So, hello beautiful people. Welcome to round number 1. 5 minutes of typing exercise, 30 minutes of bashing my head against something. I keep my progress in typing. I wrote a simple application which kind of keeps track of it for me. This is the one. Why don't you? Here we go. Okay, now it works. And as you can see, I'm trying to push the error rate, which is this guy over here, towards the 0. And this is for the all-time average. This is for the last 7 days, for the last 3 days. So we are pushing it down. That is nice. So without any further ado, let's get into it. I'll start the timer. Let's go. That felt nice. 2%, very, that's excellent. That's excellent within this land. 241. Maybe it helped that I actually slept this night. And the lesson was also short, so there's that. Hey, far, yeah, it was there before. It is there all the time. Oh, come on. Okay, that was a little bit worse. 540. Oh, well. So we will log in this amount. 540 is the result. And that brings us to... Yeah, I wrote typing Scala, but I use this page, the typing.io, and I just cycle through all of the languages, you know. So one day I do C, the other day Java, and then Scala. I use it because of the special characters, because like the normal pages which teach you how to type, you know, they don't have that. And as a programmer, I do type those characters, so I like this site. So where we are now at 4.12%. Well, we can tell, you know, like normal, like without, I don't even know. Like my average for last 3 days typing code is 38. And that's anything that really matters to me right now. But I don't type fast, you know. I'm not fast typer. I'm trying to improve it, but the reality is somewhere else at this moment. So this and it might be already. Oh, hold on. Come on, work with me. Here we go. So that the last one was 3:05. Today is 06. Yeah, so this one has been already passed for 24 hours. Okay, so we will put in the default one here. Background image, change default. Okay. You can change this background with your channel points. I hope I didn't turn it off. Sometimes that happens. Channel points. Yeah. Yeah, I can even enable all the other ones. Sure. It's there. What is there? Yeah, it is there. That's the point. Yeah, this is how it should look like. Oh, you mean like in the... Yeah, thank you. I'm a little bit slow today. Okay, so what we are doing the spring thing. So we are doing this. Okay, the JDBC. God damn it, I need a database. I probably need MS SQL database because so the tutorial has that. Well, let's just get into it. It's over here. So the aspects we did. So I'll start the timer. And let's see. Configure data source in your Spring configuration file. Then dependency injected shared data resource. They are DL classes. Okay, so I have something, what is it? Yeah, Swarm recommended this thing. Yeah, now I will be learning Docker. Okay. Minutes. Hey, Biggie. How many deaths there are? What? Many, my friend. Like deaths. COVID-19. There are many sites like that. Well, currently I'm trying to learn Docker in order so I can run the SQL, my MySQL database inside of a container, so I don't have to install it on my computer. So it would be removable easily. So I have got an image in here. Where is it? Yeah, here, which contains some Docker image called vars. But I can imagine what it will be. I was learning, you will like never learn until you try, so I didn't try. Yeah, sure. It's important to try things. Oh, maybe it will be enough in here. Okay, so what I want is to install Docker, then run this image in it, then expose the port so I can access database which lives in that Docker image outside of it. Okay, so take tutorial on this in the cloud. For Windows, yes. Commands, save. Yeah, it will take a while. Bum, 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 bum. What can I do meanwhile? Look at the tutorial. Okay, we can have a look at this.
So why Docker? There's a problem right now. We have a lot of individual machines, VMs running with OSs running in those, whether it's on bare metal or inside of a VM. And these operating systems are hard to maintain. They're hard to keep up to date. You have to patch them with security patches. You have to install all the dependencies. And you have to upgrade the operating system. And then you have to install your application code on it and configure that. I used to work at a large computer manufacturing company here in Austin. I won't mention the name, but we had hundreds of servers in our data center just for the e-commerce platform that I worked on. And you can see here on the screen that we had over 100 servers just for our browse and our www layer, 50 in each data center, 100 for being able to configure your purchases. So when you would go onto the www layer and find a laptop that you liked, and then you would choose it, and then you could configure it, add memory to it, and those type of things. So we had hundreds of servers there, 50 plus in each data center. And those are just two of the services we had. We had multiples, right? And these machines were very hard to keep up to date. We had scripts that we would run to update these and deploy application code, to install security patches. But we had to keep a list of the servers in a file, and sometimes that list wasn't always kept up to date. Someone would fat finger a server. So this led, not all the machines would get updated, right, when we tried to update them, even with application code or a security patch. And this led to intermittent errors. So a user would come to the website, they would see a laptop that they liked, and they would choose that, and that request would go to a server. Well, if that request hit a bad server, they would get an error. And so what the user would usually do is just hit refresh, and that request would go to another server, and that server could have been fine. And from there on out, they could have hit all normal servers the whole way out. And we would get these errors, and it was because one of the 50 servers in the data center wasn't configured correctly. And so to try and troubleshoot this was a nightmare. You had to look at multiple layers. So we really thought of our servers as pets. We wanted them to stay up and running for long times, 5 nines uptime. And when one went down, we'd pull it out of the layer, we'd try and fix it and heal it and put it back into the layer. It was just really hard. Well, Docker has a solution to that, and containers are a solution. And so what if we could take our application, its OS, all of its dependencies, its configuration dependencies, and bundle that all up, right? And let's call that an image. So you're able to take that image, deploy it out onto a server. You could deploy multiple images on those servers. And then if one of them goes down or two of them goes down, you just put a new image out there and the application's back up and running. No longer do you have to pull that server out of the system, try and fix it and patch it. You just deployed a new image to it. And these are all copies of each other. So you don't have to individually configure each one of those applications running on those servers.
Oh my god, I have... What?
Look at our servers and our applications as
I have to restart.
Short-lived. So if they died or went away, that's okay. We just replace it. Docker really focuses on three kind of phases in this new world. So we focus on building images, shipping images, and running images. So if you could build your image and consistently package everything up into one image, then you could easily ship that image anywhere you wanted it. And this allows you to, you could ship to a local developer, another developer that's on your team, and they can easily run that image, right? Consistently run that image. And this leads to all the things you see nowadays. So CI/CD, continuous integration, continuous deployment, being able to run your applications easily and test them through a production stage, UAT, all those type of things. You can run different versions of your application locally. You can run different applications of vendor software. So sometimes I run a different version of Mongo side by side. And it allows you to do things like rolling forward.
Yeah, sure, but
about before. So when your application goes down or you find a defect in your application, the developer is able to fix it, and then through its CI/CD pipeline, just deploy that new fix, and you don't have to pull it back down, try and fix the code in live production or anything. And the easiest way to get started with Docker is to download Docker for Desktop. And you can find that. You can see the URL here on the screen. Just go to that website, choose whether you want Mac or Windows, and download it, and follow the install steps. It's very simple to get started. Okay, so let's jump over and take a look at this. What we're looking at here is a Docker file. So a Docker file is used to build your image. So you can think of the Docker file as just a list of commands that get sent to the Docker engine, and the Docker engine starts at the top and reads down through those, executing each one in turn, and builds your image. So the first command we're going to give Docker is from. And when you build images, you usually start out with a base image. These are verified images that live up on hub.docker.com, and you can start with a base image that has everything you already need in it. So this application that we're taking a look at here is a Node application. So I'm going to use the Node base image. So it already has Node installed in it, has npm installed in it, has yarn installed in it if you're going to use that. And so we tell Docker start with that Node image, and then we're going to build on top of it. And so the first command we give it is the from. And we say from Node, 12.16.3. 12.16.3 is the tag of the Node image we want to use. 12.16.3 is the latest long-term supported version. And so the from command tells Docker, use this Node version, this image, and we're going to build on top of it. Then we use the working directory. So what the working directory command tells Docker to create this directory /code and use that as our working directory. So all subsequent commands will use that directory. And then on line 5 here, we set up an environment and variable with the env, and we name that variable port, and we assign it 80. And so environment variables will then be able to be accessed by any processes that are running inside your image. And then on line 7 here, we copy in our package.json file. We copy that into the image, and we put it into code package.json. Package.json tells Node what modules we want to use, what our application requirements are. And then we use a run command. So everything after the run command, Docker will execute. So it's going to run npm install inside of the image. And npm is the Node package manager. Node package manager, we'll use package.json. Look inside there for a list of dependencies. We'll download those and put those into the image. And then on line 11 here, we copy everything that's in our working directory in the local directory denoted by the dot. It's going to copy all that and put it inside the image in the code directory. There's also this file that you can have on your local machine. It's called a Docker ignore file. If you use a Docker ignore file, it's very, very similar to your get ignore. And you just list out what folders you don't want to be included in your image. So copy will take everything, and I'm using the dot to say in the current directory, take all that and put it into my image. And then on line 13 here, we use the command. The command is used to give the engine the default command that it should run when it starts our container. So when you tell Docker to run your image as a container, Docker looks at the command and says, okay, I'm going to run node, and I'm going to pass in the node the source server.js, and that's the application. That's the command it's going to give to our image to run. Okay, so we started at the beginning. We used a base image called node. We set up our working directory. We created an environment variable named port. We copied in our package.json on all of our application dependencies. Then we ran an npm install to install those dependencies into the image. And then we copied all of our source code into the code directory. And then we told Docker, call node and pass it in server.js when you start this image. So let's jump over to the command line. Let's build our image. So the way you build an image is there's a Docker build. And I'm going to do run a help so we can see what options you can pass into. So if you look at it, I'm going to look at two options real quickly. We have the tag option. And so that's how you name and then optionally give it a tag. And it needs to be into this format. So name : tag. So we look back at our Docker file. That's what Node did with their image. They said node : 12.16.3. Right? So we can do the same for our image. And then the second flag here is the file, -- file. And that tells you where the Docker file is located. The default is just whatever the path you give to it. It'll look for the name of Docker file with a capital D. So you can see here we do Docker build, pass in options, and then we give it a path. So let's go ahead and do that real quick. So we're going to run Docker build -- tag. I'm going to call it hello - world. The path is just going to give that current working directory. Let me show you here in our working directory. You can see that we have our Docker file. Okay. So let me do Docker build -- tag. I'm going to give it hello world, and then I'm going to give the path as a local directory. So let's run that. So you can see here what Docker's doing is it pulls in our Docker file and starts executing the commands. Right here you can see step 1 of 5, and then 2, 3, and down. You can see the from command, the working directory, the copy, and so forth and so on. So it runs all those commands, and then it writes our image, and gives it a SHA, and then it'll name our image as hello world. So let's clear the screen real quick. Now see the list of images that you have on your local machine. You do a Docker images. So there we go. Here's a list of images I have on my machine. You can see the hello world image that we just built. All right, okay. So next thing, we had a Docker file, which we told Docker how to build our image. We did a Docker build, built our image, and you can see it. We just looked at it. Now we want to run that image. And so Docker has a run command. So do Docker run. I'm going to do -- help so we can take a look at it. Now the run command has a bunch of options you can send into it. You can do things like run it detached. You can set CPU limits. You can tell what DNS to use. All kinds of different things. For right now, we're really just going to run.
So what they're doing, he's creating the image, right?
So I'm going to run Docker run hello world. So we run it. And now we're listening on port 80. Let's go over to our handy dandy browser here. Let me refresh. Oh no, not this coming up. That's because your containers are run in isolation. So basically, a container is just a process that's isolated from the rest of the system. It has its own file system, it has its own network. It's restricted to CPU and memory usage. And so we didn't give it any ports. We didn't map out any ports. We didn't connect it to a network. So when in the browser, when we try and connect to it, we're not able to connect. So let's do that. So let's give it. Oh, real quick, I want to show you. So right now we have. Let's look at what's running. So to see if anything is running on your system, you can do a Docker PS. They'll call it processes. PS for processes. And we don't see anything running. But if you do a -A, that will show you everything. And we can see our image that we had run above here in this run command. We can see the image hello world. Here's the container ID, Shaw. And set it exit about a
Okay,
minute.
so you run it just by Docker run, and then you say the name of it.
This name,
Okay,
crazy buckaloni.
that
If you
seems
don't
to be
name your
easy.
images, Docker will name them for you. And so we can see we still have that same image there. So let's remove that image. Well, before I do that, you can also start your Docker images. So let's do Docker
God,
start,
I'm
just click on the
tired.
image, and it's back up and running. Let's do a Docker PS, and there we can see that it's running. Up 5 seconds ago. So let's stop it. So we do a Docker stop, and now do a Docker PS again. And we see that it stopped, and if we do a Docker PS -A, we can still see it's there. So let's remove that image now and clear the screen. So we do a Docker remove and give it the name of the image. So now if we do a Docker PS, we won't see it because it's not running, and we'll do a Docker PS -A, and we can see it's been totally removed. Okay, so let's take a look at our images. So again, to see what images are local, you do a Docker images. So now, remember when I first started it, we weren't able to connect to it in the browser because we didn't allow our container to have any access from the internet. I'm going to expose a port, so I'm going to do a Docker run, and I'm going to do -P. I'm going to give it 8080:80. So I'm going to map port 8080 on a local machine to port 80 inside of the container. Then I'm also going to name it because I don't want Docker just to give it a random name. So let's call it hello. You can run your container in the background detached. So for long-running processes, such as Node, a web server, we just want it to run in the background as detached. So we can give it a -D that'll run it as detached, and then we'll give it the name of the image. And so now we're running. When you do a -D, Docker will spit out the container SHA, the container ID. So to see our container running, we do Docker PS.
Hold on.
And so now we're running. When you do a -attach, so we can
Docker
give it a -D
images.
that'll run it as detached, and then we'll give it the name of the image. You're gonna give it 8080. Images are local. We won't still see it's there. So let's remove that image now and clear the screen. So we do a Docker remove and give it the name of the image. So now if we do a Docker PS, we won't see it because it's not running, and we'll do a Docker PS -A, and we can see it's been totally removed. Okay, so let's take a look at our images. So again, to see what images are local, you do a Docker images. So now, remember when I first started it, we weren't able to connect to it in the browser because we didn't allow our container to have any access from the internet. I'm going to expose a port, so I'm going to do a Docker run, and I'm going to do -P. I'm going to give it 8080:80. So I'm going to map port 8080 on a local machine to port 80 inside of the container. Then I'm also going to name it because I don't want Docker just to give it a random name. So let's call it hello. You can run your container in the background detached. So for long-running processes, such as Node, a web server, we just want it to run in the background as detached. So we can give it a -D that'll run it as detached, and then we'll give it the name of the image. And so now we're running. When you do a -D, Docker will spit out the container SHA, the container ID. So to see our container running, we do Docker PS. There it is running. You can see the name's hello, and now you can see that we mapped port 8080 into port 80 in the container. So let's go over here to the browser.
Okay. So this is like the port 8080 on this machine is to that. Ah, that's great. So I will take, and somehow now I have to do it for
80 in the container.
For the database, which is here. So here is okay. So here's how to get it. This is, well, yeah. So this is the general thing. I can build it. I don't care about that. Persisting is nesting. Well, now I found out like how to, based on this video, and that I will be able to. I'm getting to what I want to do. That is getting the container, the image of it, run it through the Docker, and then exposing the port, which would service my application from there. Configuration, setting the root password, no. Okay, sure, blah blah blah, allowing empty passwords, setting character, creating database on first run, okay, cool. User on first run, how do I connect it? Replication cluster, I don't know what the replication cluster is. What just happened? What the fuck? Oh. Logging, maintenance, upgrade this image. Okay.
So let's go over here to the browser and let's put in port 8080. And there we go. We can see it running. Now we can stop that. Do a Docker stop. Hello. Okay, it stopped. Now we don't see it. And we do a Docker PS to show us our running processes. It's not there, but if we do a -A, there it is. And again, you can start that container back up. Do a Docker start. And we'll just give it a hello.
Hey, Colonel.
That's how you start and stop your containers. That's how you build images.
Just trying to learn Docker in order to run a database in an image in container.
So now that we have it running, what if you run your container in the background?
For my Spring application.
Docker logs, and just give it the name of the container. And you can see there, it's listed on port 80. We stopped the server, and then it's listed on port 80 again. You can also run a -F on the log.
Oh, really? You did? I didn't. Oh, come on. What's happening with this thing? Why the Discord is frozen? No. Right, okay. Fuck's sake. In the keyboards. I see, in the keyboards. Oh, nice. I cannot put it on screen for some reason. But very nice. So I did some cleaning and replacing the switches. That's pretty neat. How are the new switches?
So let's look at the help here real quick. And you can see a -F or -F follow. So that allows you to follow the log. So if you're running an image locally and you're having a problem with it, you can attach and follow the logs.
Like, why is the fucking freaking stupid Discord not doing what it's supposed to do? Hold on, I will kill it here. Yes, and then I'll start it again, and hopefully that will work. Oh, are they? Is it so much better? Okay, now it works. Yeah, here it is. I'll put it in here. Really dope. And like, what is the difference, really?
Out of watching logs, you just hit a Control-C. But that did not stop our container. Our container is still running. So let's stop our container. Hello, and then Docker PS-A. You can see it's still there. Let's remove that container. So we Docker remove. Hello. Now we should not have it running. But we still have our image. So we look at building an image and running an image. Now let's look at how we can share that image by pushing it out into Hub. So let's go back to our browser and let's take a look at Hub. So Docker Hub is where all your base images can live. It's a repository for images. And it has some auto-build capabilities. It has some CI/CD capabilities. It has some organizations and teams where you can set up RBAC, rules-based access control for your teams to give them access to your images. So you need a Docker ID. So you log into hub.docker.com. If you don't have a Docker ID, you can sign up right here. Of course, I already have one, so let me go ahead and sign in.
So you will replace all of them now for the new one. And also lubricated still is with electric. They're really yeah.
Okay, so I'm signed in. This is the dashboard. We see.
Today I will be upgrading my keyboard to. I will replace this part with a different material, which should be more like sticky than this one. So yeah. I will leave in a few to get it. The package arrived.
So let me create a repo. I'm gonna give it the name of Hello World, and you can give it a description if you like. Then you can mark your repos as public or private.
Hey, Daria.
So if you're connected to GitHub or Bitbucket.
Let me get the water. Where's my water? Where's my water? Where the freak did I put the water? I don't even have it at the desk. Cheers. Okay, so this concludes this round.